What's the world going to look like in 20 years? Or what if I told you that the future already exists because the world's smartest people are busy dreaming it and building it? The future is coming fast, and your world will never be the same.
Want to live forever? New research is transforming immortality into a reality. Clone yourself into an avatar to live forever in cyberspace.
That's a creepy wink.
Extend your lifetime by slowing your heart down to 1 beat per minute.
It's alive!
With suspended animation straight out of sci-fi. Then, when your old heart wears out, just print yourself a new one.
Instead of using ink, we use cells.
Meditate like a Zen master to put old age on ice.
Cold is a noble pose.
The future of immortality. Let's do this.
Imagine what the future holds. Airborne taxis, cities alone. Puppies on a hovercraft, leave now and home. Imagine what the future holds. Popular science, the future beholds.
My name is Baratunde Thurston. As a journalist and blogger, I've made it my business to keep my finger on the pulse of technological change. What's the world gonna look like in 2030? Get ready to see the future.
Every heart has a fixed amount of beats in it before the muscle just quits. My liver, my kidneys, my lungs all have the same limited lifespan. Deterioration and disease are inevitable. It's called aging, and it always leads to the same end, death. These guys aren't buying that. They've decided to go toe-to-toe with the Grim Reaper, bringing scientific solutions to the dream of life everlasting. What if you could buy a warranty against organ failure? Just trade in the old clunker for a brand new model, grown from a tiny piece of your own tissue. Or how about a drug that keeps your cells fresh and young in a state of suspended animation? This is me on my computer today. I type, I read, I find information. But that information lacks a certain personality. But in the near future, I'll go online and interact with an actual human mind. We'll be able to access anyone who has ever lived through a computer-generated version of themselves, an avatar.
Hello.
Suddenly, death has become obsolete.
Yo, Baratunde! 1,000 years from now, I'll still carry on your legacy looking as good as you do today.
This is the Electronic Visualization Lab at the University of Illinois in Chicago. Here, cyber scientists Jason Lee and Ram Damara have an undying interest in perpetuating personalities with sophisticated software.
The goal of Project Lifelike is essentially to begin to understand how to create digital replicas of humans. The only way we can do it nowadays is through either text or pictures or video. So Project Lifelike will hopefully add an interactive component of it using advanced computer graphics so that you can also converse with this virtual representation of you.
What we're trying to do is have the avatar dynamically adjust based on conversational cues. That's something very essential to making an avatar appear realistic and appear lifelike, but that's very elusive.
This is Alex the Avatar. Alex is the digital double of Alex Schwarzkopf, a former director of the National Science Foundation. When the NSF began funding Project Lifelike, Alex saw an opportunity to have top scientific minds make him immortal without even becoming a Bond villain. Right now, Cyber Alex comes alive only when he's turned on. But down the road, he'll be like the old Max Headroom, living online 24/7, standing in for the real Alex, and even appearing several places at once. Avatar Alex combines CGI realism with just enough artificial smarts to pick up verbal and non-verbal cues. In other words, he doesn't just speak, he converses.
Hello there. Are you an evaluator, director, or friend of NSF?
Yeah, he's not exactly Mr. Personality yet. He still relies on generic facial expressions, and his idea of small talk is not the sort of thing you want to blog home about.
I am happy to tell you all about the IUCRC.
I've been so curious about National Science Foundation
Right,
policy.
right.
Thank goodness you've set this up.
It's what pays the bills.
He may not yet be a riveting dinner guest, but the fact that he can hold a conversation says a lot. Let's see what he's got.
Me. Awesome.
Hello, friend. So, what is your name?
Hi, friend. My name is Baratunde.
Ron, I couldn't understand that. What was their name?
Baratunde. Baratunde.
I get that reaction a lot.
And he's just going back to typing. Oh my goodness, this dude is so rude.
Maybe this wasn't a fair test. You see, like most of us, Alex only understands words that have been downloaded into his brain, and they have to be spoken just so. Let's give him another shot.
What is your first and last name?
Baratunde Thurston.
Well then, I'm Alex.
All right, he heard me.
CRC Program Director. I'm a strong believer in project collaborations. What day of the week do you leave this conference?
Tomorrow.
Would you like to meet John Ringo from Washington State University before you leave the conference tomorrow?
Sure, why not?
Okay, I will try and introduce you to later today. I am happy to tell you all about the IUCRC.
No thanks. I know everything I need to know.
Very well then. Please let us know what you thought of the experience. Keep the peace.
Keep the peace?
He really says that.
Really?
Actually,
That's
yes.
his thing?
Yes.
So that's you getting his personality in a bit.
That's part of the conversation.
Yeah.
Customization.
So what makes this so special? I mean, where do you see this stage of Alex?
This stage of Alex is quite an improvement from a text-based user interface to an expert system. A long way to go to being a human being, but...
Yeah, he cut me off at the end there.
He can be a little rude. Depends on his mood.
While he's as clumsy and socially challenged as a few programmers I know, Alex is the first step in a process of immortalizing humans that could go on forever. An avatar of you could one day be chatting to your great-great-grandchildren about the good old days of the 21st century.
Is there anything else you want to know about the IUCRC?
Alex's brain consists of a speech recognition engine that identifies key phrases and words.
International collaboration. International collaboration.
The words then pass through a contextual knowledge engine, a kind of encyclopedia of everything Alex knows. Alex sorts through all the matches to figure out how the words are being used.
International collaboration.
And come up with an appropriate reply.
One of the main objectives of NSF is to commit to broader impact and outreach.
He also has a pair of eyes, well, cameras, which pick up the speaker's expressions. Alex searches his memory for what each expression means and uses that to help guide him to the most appropriate of his pre-recorded replies. Eventually, as his memory expands, he'll have enough data to synthesize his own original responses. No more prefab robot talk. Of course, if I'm going to live forever, I don't just want to act natural. I gotta look good. That's a job for Jason Lee, who's about to create a virtual me that my great-great-great-grandchildren can be proud of. First, you gotta have them move, so I put on a motion capture suit that's studded with sensors from head to toe.
This feels very alien. Am I gonna start picking up signals from another planet?
So right now the computer is figuring out exactly what the full range of each of your body parts are. What you're seeing here are what the computer sees as each of the individual dots that are attached to your body. Okay?
On the first pass, the sensors record my basic movements. But if my avatar is gonna come off as the real me, this thing needs to get in sync with my unique body rhythms. Done. 1,000 years from now, I'll still be able to bust a move. But if I'm going to live forever, you can't forget my face, and that's a tough one. Some 4 dozen muscles are at work moving precisely shaped physical features into hundreds of expressions that all add up to me.
going to take the photographs that we took and apply them as what we call texture maps onto the surface of the model.
Jason takes photos of my head and maps them one stage at a time onto a 3D computer model until...
Whoa, what's up, sexy dude? What'd you do with my hair, man?
70% of all communication is nonverbal, and my avatar is programmed to replicate the basics, including some expressions I hope I'll never need.
Oh, no, not angry. That's not good. The smile, that's more me. That is the sexiest avatar I've ever seen.
Whoa, what's this?
That's a creepy wink. You have to work on the wink. I'm telling you right now, send the wink back to the lab.
All right, my avatar can smile and freak people out. I can do jumping jacks and cut the rug. One last thing, I need some threads.
Whoa, you made me an astronaut. That is so cool. I didn't even have to go to flight school or anything.
Exactly, and hopefully everyone will be able to do this for themselves in the future.
So in the future, you see people, even with their laptops, being able to sort of scan themselves without having to... Well, they're going to miss out on this beautiful process and this leotard-type skin suits. You have now immortalized me as a dancing, space-flying astronaut.
Exactly.
Thank you so much, Doc.
As much fun as I've had making a complete avatar of myself, I'd hate to be immortalized as a beta version. But Baratunde 5.0 isn't that far off. Avatar engineers are aiming to create cyber doubles that are as natural to talk to as the real you. Today, when loved ones die, they leave us with only memories. But in the future, their avatars will be so lifelike, they'll interact with us long after their bodies have gone.
For as long as people have been living, we've been trying to avoid death. And through Project Lifelike, we have experienced a small slice of immortality.
Coming up, we'll see movies of thoughts in action that could permanently preserve a human mind. And later, a mouse achieves the dream of suspended animation.
You are getting very sleepy.
The future, behold.
If we want to download and preserve a human mind to live forever as an avatar, we first have to figure out how the brain works. Exactly how does it conjure up thoughts, tap into memories, and rev up the emotions that make you, you? What's going on in there? At Harvard University, neuroscientist Jeff Lichtman is pioneering an astounding breakthrough in brain scan technology called Brainbow. These colorful collages are an illustration of not just the neural pathways, but actual brain activity. Not just the freeway, but the traffic. In this case, in the mind of a mouse.
Ultimately, these diagrams signify all of the wires that underlie everything that we are, all of our memories, everything we've learned, every bit of our personality. This big tree you're looking at is a bunch of wires. These wires are the connections that take place between brainstem neurons and muscle fibers.
To chart this cerebral circuit board, Lichtman takes genetically engineered mice and injects them with fluorescent, multicolored proteins found in jellyfish. As the mouse thinks and acts, the fluorescent proteins spread out along neural pathways, causing them to light up like a brainbow. Next, these kaleidoscopic mouse brains are sliced into layers 1,000 times thinner than human hair and laid out on film-like strips. The microscopic landscape of the brain is magnified 10,000 times. To the ordinary eye, they look like a day-glow diagram of rush hour traffic in Mumbai, but they actually depict the intricate pathways of thought with unprecedented precision. In this cross-section, you can see several large, round brain cells. They're smothered in a thicket of axons and dendrites, the communication lines that wire the cells together. Hundreds of brilliant colors are used to distinguish each pathway.
And anyone who has a computer monitor or a color television knows that just with R, G, and B, those three colors, one can get all the colors that humans can see.
Slice by slice, scientists can track everything that's happening in the brain and map it down to the last neuron. But the task is monumental.
We've completed the wiring diagram of one teeny-weeny little muscle that wiggles the ear of a mouse, and it took about 6 months to do a whole brain. At present rate would take 1,000,000 years.
Not willing to wait that long, Lichtman will distribute the work to thousands of scientists. If all goes well, an entire human brain could be mapped out in only 40 years, producing a schematic for turning thoughts and feelings into a perpetual program that could live forever online.
Some people have thought that maybe if you had the wiring diagram and you put it into a computer, you could make a computer think like a human being.
Wow, that means my avatar won't just know what I know, it'll think like I think. My mind will be immortal. Of course, immortality is cool if the mind stays sharp. An infinity of senior moments would ensure that nobody would log on to you. Fortunately, brain detectives like Dr. Andre Fenton of the SUNY Medical Center are working on methods to keep our cyber brains forever young.
Until now, we had no concrete idea what memory was. We didn't know how to weigh it, we couldn't point to it, we could only imagine such a thing was.
But it just may be that memories have a physical structure. Andre's research centers around a molecule called PKM-zeta. He's observed that it clusters around synapses, and this could mean that it's responsible for creating and cementing long-term memories. To test this theory, Andre devised a shocking experiment that shows scientific research can be a bit of a rat race.
He'll explore the arena, and the computer will turn on an electrical shock that will make it unpleasant for the rat if he enters a particular part of the rotating space. And the rat, like a normal person, doesn't like to get shocked, and it will stay away from this part of the floor.
When the rat first enters the cage, it sniffs about freely and checks out every inch of its new turf. After a short period of shock therapy, it's learned its lesson and knows which slice of its world to avoid. Theoretically, the memory of the mild pain has become fixed in the rat's brain. Andre then injects the rodent with a molecule called ZIP, which blocks PKM-zeta from binding with the synapses.
It causes the specific synapses to dissipate, okay? And with that dissipation, okay, goes the information.
Sure enough, the rat ventures back into the shock zone. The shock is off, but the rat doesn't know that. Evidently, its memory of the pain has been erased.
Your brain will have removed everything that is stored in the part of the brain that our inhibitor would affect.
The hope is that learning how to delete memories is the first step in knowing how to store and revive them. With this capability, we could perfectly preserve every experience in life for our cyber selves. Or, in the case of traumatic experiences, we might eliminate memories that we just as soon forget. Andre Fenton's work could one day give all of us total recall, vivid recollections of anything we want to remember, for as long as we live, or even longer, maybe even forever. If I can get an indestructible memory, then I'm one step closer to immortality. Living a long life is an age-old dream. But what if you wanted to skip over the immediate future, or were slowed down by an illness for which a cure is decades away? Mark Roth, a researcher at the Fred Hutchinson Cancer Research Center in Seattle, has figured out a way to put people in a state of suspended animation. That ultra-laid-back state of being that puts your metabolism on hold for fresh keeping. It's here, thanks to Mark, who has a professional fascination with the biology of taking it slow.
I started to think about creatures in the world that don't do anything. Like in hibernation, the winter, ground squirrels and such, bears hibernate. They don't do anything.
Or high school seniors.
High school seniors, like my daughter is doing nothing
today. There you go. She's practicing immortality.
Right. That's right. We also see it in near-death experiences for people.
Okay.
Where they do nothing and then they come back and re-enter an animated process.
And then reanimate.
And we say they came back from the dead, but they were actually just suspended. I thought if we were able to cause creatures to enter into this state of suspended animation, we might be able to dodge death.
The idea of kicking back and power napping for a few years is appealing. Mark woke up to the idea that humans could do something like that, and that oxygen was somehow the key.
Right now, 1 out of about every 5 air molecules we breathe in is oxygen. If we reduce the amount of oxygen by a factor of 4 to 5%, then we'll be dead in about 5 minutes.
Okay, so it seems that the more we reduce oxygen, the more dead we end up. While experimenting with microscopic worms, Mark discovered something that seemed to make no sense. If you reduce oxygen even more, from 5% to almost 0, something amazing happens.
When we went 100 times lower, we found out they were no longer dead.
Wow, okay.
And yet they were doing nothing. So they had moved from living and animated to suspended. And they could sit there for days. And then we thought we've really captured a different state of existence than people had recognized previously.
It's enough to take your breath away. A new state of being that hovers between life and death. Coming up, a mouse that occupies a biological limbo.
It's alive!
And later, a meditation master fights old age by staying cool.
You reverse the process of aging.
The future, behold.
At the Hutchinson Cancer Research Center in Seattle, Dr. Mark Roth has discovered that he can make worms slip into an ageless state of suspended animation by reducing their oxygen levels to almost nothing. And he had a hunch that the same might be true for other species, including us. The trick was to find an alternative way of reducing an organism's oxygen intake. Just dialing down the air supply worked for the worms, but wouldn't work on higher life forms. The breakthrough came in a gas called hydrogen sulfide. One whiff of it at a high enough dose and you'll be dead within seconds. But at lower doses, it acts as an oxygen regulator inside our cells. There, mitochondria normally turn oxygen molecules into energy, but H2S stops oxygen from bonding, causing the cells to shut down. If you get the dosage right, this process causes no lasting damage.
1/10 of 1% of the air you and I were breathing, or hydrogen sulfide, we'd go like this, and then we'd drop to the floor.
Wow.
Just like that.
Okay.
And then if they took us to an atmosphere that was regular air, in a few minutes we'd wake up and go, what was that?
Mark tried minute doses of the gas on zebrafish, and it stopped their hearts for 5 hours. But when he removed the hydrogen sulfide from the gas mixture, the fish came back to life. With such promising results, it was time to take the experiment to the next level. We're about to put this mouse into a state of suspended animation, a time-stopping, no-aging process that could someday make resurrections routine. First, we introduce a tiny amount of hydrogen sulfide, just 80 parts per million. It's enough to bring down the mouse's metabolism to almost 0.
It usually takes a few minutes, but you're gonna start seeing, and you'll see his behavior changing too. He's gonna stop moving around quite so much, and they end up laying down, which mice don't do very much, but they end up laying down quite a bit here.
Yeah.
Does it help to say you are getting sleepy?
Yeah, that's it.
After 10 minutes, the H2S is hitting the mouse like a triple martini.
Yeah, so now you can see the posture of the animal with the paws tucked. This is very stereotypic of a hibernating or meditating mouse.
The meditating mouse.
The mouse's metabolism has dramatically slowed down. Instead of a normal heart rate of 120 beats a minute, it's down to just 10. And its body temperature has plunged from 98 to 59 degrees. Normally, that's not enough to sustain life, but here we're putting it on pause, in a state of suspended animation.
Now that we've got this meditating mouse, can we bring him back?
Sure we can.
Whoa! What's he reacting to there?
He's recognizing the room air is starting to come in.
And there's the line in the chart.
He starts to move around.
It's alive! It's alive!
He's starting to produce carbon dioxide.
Right, so the red line's going back up again.
As it turns out, mice aren't the only mammals that can zen out into metabolic meditation.
Every creature we look at can do this thing of entering into suspended animation.
So we all have it within us. We
all the creatures
broadly defined.
That's right.
Mark Roth's work could revolutionize emergency medicine by freeze-framing the victim of a heart attack or stroke until he's transported to a full-service hospital.
Instead of giving someone oxygen to try and revive them immediately, you instead reduce their ability to do metabolic activity to buy time for them to take the emergency out of emergency medicine. Another way to think about it is to slow down time for the patient while everybody else moves as quickly as they can. You don't want the patient trying to move quickly metabolically, because that's just going to take them to dying.
In just a few years, IV hydrogen sulfide hookups could be standard equipment in ambulances and ERs. Mark has already converted the gas to a liquid and bottled it under the name of a company he started called Ikaria. The H2S could really buy time if the body's in a bad way. But even the perfectly healthy might find decelerating on demand an attractive option. You can buy time in a bottle. The right dose of hydrogen sulfide could cool your jets for 12 hours. And when you wake up, you're not only rested, you're a day younger than you would have been.
Our instinct is to rush and do more. Mark Roth wants us to do less. He foresees a future in 10, 20, or 30 years where we manually control the dimmer of our lives, where we can dim on demand in a park on a Tuesday afternoon when we just feel like checking out for a few seconds. Scientists have known that the keys to immortality lay within the cells in our very body. What Mark Roth has shown us is how to turn that key to open the door.
There's another door to adding decades to your life that doesn't require magical gas, conscious computers, or any store-bought super science. It's the simple, traditional practice of meditation. And Wim Hof, a meditation master from Holland, is bending over backwards to demonstrate the meditation longevity connection with some cold, hard evidence. He can enter a meditative state and relax in a tub of ice water, controlling his body temperature, heart rate, blood pressure, and any other physiological response that relates to extreme stress and aging.
So they call you the Iceman. And you're gonna teach me about relaxation, about controlling my nervous system and my immune system?
I'm the Iceman with the warm heart. That's because of the blood circulation, but I'm gonna explain it all.
Wim Hof is a master of Tumo, or inner fire meditation, an ancient practice from Tibet, which enables him to control the thermostat for his body and his brain. According to the doctors who've tested him, Wim's mind can grab hold of a key bioregulator called the vagus nerve. It starts in the brainstem. It's what regulates blood pressure, heart rate, and the production of antibodies. If Wim is under stress and he meditates, his antibody count shoots up and reduces inflammation, a major symptom of illness and old age.
Inflammatory bodies are the cause of our aging. And if you can intervene in the process of anti-destruction, then imagine what you can do in your life.
We're going to test Wim to see how powerfully his meditation affects physiology. We're gonna put this cool customer into an ice bath so cold, a normal, non-meditating test subject would quickly slip into a state of shock. They'd black out in less than 15 minutes and die shortly after that. Then, after he's done, he'll show us that anyone can benefit from meditation, even someone as warm as me.
Yeah, it looks ridiculous, but I'm gonna have you in an ice bath today.
You're gonna have me in an ice bath?
Yeah.
But you're the guy who's been training for years and years and years. I'm pretty sure I'm gonna feel cold.
You know, it's quite a challenge for me to make you feel impervious to what the cold today.
Yeah.
To help us understand what's happening as he chills out in the tub, we brought in Dr. Roberta Lee, a specialist in mind-body interactions. Nurse Jane Ash is also here to keep track of Wim's vital signs. This is a highly dangerous experiment and cannot be attempted without medical professionals on hand.
So the baseline temperature is 98.1. Blood pressure, can I have your arm, please? Very clear and very normal, 120/80.
While a normal heart rate is about 72 beats per minute, Wim's is only 50, the stress-free pulse of a master meditator. But Wim has done a lot more than meditate. He's conquered myriad challenges involving extreme cold, including running a barefoot marathon in the sub-zero Arctic, dressed for summer camp.
38 seconds. Here. See, my hand is cold right now. This hand, cold. How are your legs?
Good, good, good.
Are you doing breathing exercises? Are you visualizing something?
I'm beginning, but I first want to have all the ice.
Okay.
The process is working right now.
Yeah?
The processes which help you learn to control yourself. Okay, this is enough.
We're now 3 minutes and 45 seconds in the ice.
All right.
Of course, a normal non-meditator would immediately leap out of the tub 6 shades of purple. Mild hypothermia could set in after just a few minutes. We all know the symptoms: shivering, goosebumps, and shallow breathing. But for Wim, it's all a day at the beach.
He's beginning to use his state of mind to access the vagus nerve.
The body temperature should drop from 98 to about 95. He should go into violent shivers, his extremities turning pale and then blue. His core temperature should continue to drop to as low as 90 degrees. But Wim's not freezing. He's just chilling.
Okay.
Wow.
98.6.
So he's warmer. Can you point that?
98.6. It's gone up.
Is that what you expect to happen in a normal, average person sitting in a tub of ice?
No, I expect them to cool down because, think about it. In medicine, we have children who have fevers, and one of the first things we do is we put them in a cold bath, and that cools them down.
Amazingly, Wim's pulse, which ought to spike dramatically in response to the cold, is also ignoring the shroud of
And his
ice.
heart rate has remained the same at 50.
You're still normal, Wim.
Nobody says that I'm normal.
It's as if there was no ice.
The Iceman stayeth, and the only thing that reacts to this deep freeze is his blood pressure.
140 over 90. From 120 over 80.
But it's still close to normal, and nothing like the physiological freakout that non-meditators would experience. Somehow, deep Tumo meditation seems to allow Wim Hof to take charge of his vagus nerve. Through it, Wim appears to consciously regulate his heart rate, his blood pressure, and his body temperature. Since the vagus nerve is also hooked up to the immune system, Wim seems to have the power to fight off disease and aging, using only his mind. Coming up, Wim teaches me the secret to a long life and baptizes me in ice.
Good.
And later, need a new body part? Grow your own.
The future, behold.
Meditation master Wim Hof has been immersed in a polar bath of ice for over 20 minutes, but his body doesn't seem to care. He's putting himself through this to demonstrate how meditation can control his metabolism, and in doing so, shield it from cold, disease, and the ravages of old age. By this time, a normal person would be slipping into severe hypothermia, but Wim?
Can you tell me what you're feeling right now and how it differs from maybe what you felt in the first 5 minutes?
Cold is a force, is a power, and I got to deal with it. If you know how to deal with that, then there is a less stress going on, and less stress means longer life. That's what meditation does, the right breathing does, and exposure to cold.
It's very unusual that he can maintain so many things close to normal. With this long, we're now at 26 minutes.
It's as if Wim Hof, through Tumo meditation, has found the control knob to his own metabolism, maintaining the normal, healthy rhythms of his body with just the power of his mind. There's a lot of evidence to support the meditation longevity connection. In one 20-year study, meditators had 30% fewer heart attacks and 49% fewer cases of cancer. Meditation also lowers blood pressure, metabolic rate, and other biomarkers of the aging process.
30 minutes and 30 seconds, so
right on.
Shake your not so cold hand.
Good.
And thank you.
Thank you, man.
And I think we've gotten a lesson here, and I'm somewhat looking forward to trying this out myself.
Good.
The incredible Iceman has done it again.
When he came out of the tub, I touched his back.
Yeah.
And it was warm. I have iced a number of patients, but never have I experienced someone in these conditions and survived.
All right, Wim has convinced me, but he's the Iceman, a meditation master. What about us amateurs? If I can do this, even briefly, then in the future, we can all tap into the power of the mind to improve health and lengthen life. Fortunately, Wim has given me a crash course in Tumo, and the basics are pretty, well, basic. Focus on the breath, breathe from the belly. And once I'm in the ice, visualize as vividly as possible warm oxygen saturated neck in pure ice. I was hoping I might last 60 seconds. I lasted 8.5 minutes. This meditation stuff is really powerful.
Honestly, I feel great. I'm not just saying that for TV. This is the greatest wake up I've ever felt, so thanks.
Thank you.
Yeah.
Thank you for the success.
All right.
You are a success right now.
To the sun. No hardware, no software, no chemical additives, just cold, breathing, meditation. We can consciously consume revolution, which explores new ways to replace old parts and greatly extend our lifespan. So how do you make an organ from scratch? You begin by building a precisely shaped frame in a process known as electrospinning. A magnetized spinning wheel teases tiny biodegradable fibers out of a thin jet of liquid collagen and wraps them into the desired shape, much like a cotton candy machine whips up an impressive wad of wonderfulness. By controlling the speed and other variables of the spinner, Anthony and his colleagues can shape a scaffold for body parts, like a blood vessel or a tendon that connects muscle to bone. Once the scaffold is built, it's seeded with organ cells and put in a bioreactor, a hermetically sealed cylinder that mimics the conditions inside the body. It's kind of a boot camp for new organs. The bioreactor forces a synthesized body part like this heart valve to work out and prepare itself for active duty in a real body. Anthony built his first bladder in 1998, and since then, he's put 20 more organs under his belt. Electrospinning is especially good for tubular body parts like arteries and veins.
The most complex organs are the solid organs because they require a lot more cells per square inch than any of the other tissue types.
But he's already mastered shapes as complex as a human ear. His current challenge is building organs that have intricate innards, like the kidney.
Over 90% of patients waiting for a transplant organ are waiting for a kidney. And by far, the most complex organ is in the kidney. It has many different types of functions and it gets injured easily. So the challenge is, how do you make a new kidney?
The answer might be bioprinting. The same kind of machine that churns out documents at the click of a mouse might someday print out the body part of your choice. Inkjet printers shoot out tiny droplets of ink that happen to be the same size as living cells. With the right kind of ink, so to speak, these cells harden into a hydrogel and are built up layer by layer into an organ-shaped scaffold, which is then shot through with living tissue.
But instead of using ink, we use cells. And you can do this one layer at a time with a printer until you get your three-dimensional structure that's consistent with the organ you want to create.
As with electrospinning, the scaffold is made of collagen, but it's seeded with particular cells of the desired organ, in this case, a heart valve. And the best part about these freshly assembled organs is that the body recognizes them as its own.
One of the great advantages of this field of regenerative medicine is that it can use the patient's own cells. And when you do that, there is no concern for rejection.
No rejection, no problem. This technology is already commercially available. Dr. Steven Nichtberger's company, Tingion, has got the guts, if you will, to pioneer a service of tailor-made replacement parts.
We actually have designed a manufacturing facility that has the ability to deliver custom-made organs for patients who need them. And soon, thousands of these patients will be able to send their tissues to us, and one at a time we'll be able to make organs for each of these patients and deliver it back to them.
Now that's absolutely, positively cool. Soon, we could all cruise into old age just like a vintage car. With a constant supply of spare parts, we could keep on running almost forever. Forget the fear of discovering you have terminal heart failure. In less than 10 years, you could just order up a brand new ticker. Deal.
The organ gets placed into the patient using the patient's own cells, no rejection, and that patient lives with that organ like if it were their own original organ all over again.
I don't know what's more sci-fi, organ cloning or suspended animation, mind mapping or memory engineering, living for eons as an avatar, or extending life through meditation practices that tap into the mysterious powers of the mind. The future of immortality is so close. I don't know whether we'll be the last generation to experience a normal lifespan or the first to finally break through the barriers of disease, stress, and limited technologies to radically prolong life. Either way, it's an exciting time to be alive.